The third barrier that we have in a building is the thermal barrier, which you're probably all really in tune to. We've got fiberglass blanket insulation, which we have here that's compressed between our secondaries. We've got the newer fiberglass insulation systems with our liners. This is still what's considered a cavity insulation. And when I say cavity insulation, it's filling the voids between the structure. Doesn't matter if it's a metal stud, purlin in a metal building, or anything else where the insulation and its effectiveness starts and stops. That's a cavity insulation as defined by the building codes. Over here we have continuous insulation. Two different types of continuous insulation. We've got rigid board, which we then put a single skin metal siding over, and we've got an insulated metal panel. Those are our three choices in the metal building space now, and they meet our thermal requirements in one way or another. But just so you're aware, this system and this system do not meet the requirements for continuous insulation that we're going to see here in a slide. As you can see in this picture, we have a building that was developed with cavity insulation. Each of these yellow and red lines are framing members that are going from the inside of the building to the outside of the building, and the insulation is between them as opposed to continuous in front of them. Now, this is an easy way to describe what effectiveness or efficiency of insulation is. So when we look at R value is the measure of a material's resistance to transferring heat or cool, but it's when that material is laying on the ground, not when it's installed, not when it's part of an assembly, when it's laying on the ground. The U value that the code talks about is the measure of an assembly, so the entire wall together. All of the studs, all of the girts, all of the screws, all of the clips. The U value defines the system, the way it's installed. So it's a much better way to look at how the building is actually performing. When the building codes came out with U values some years back, a lot of people came to this equation. The U value is equal to the inverse of the R value. While theoretically that is correct, it is not accurate. That is only accurate if your insulation assembly is 100% efficient. And as we can see in that picture, that insulation assembly is not 100% efficient because we have thermal transfer of heat through those framing members. So if we look over here, we have a chart, and this is a chart that is put out by ASHRAE, and it took an R25 with some foam and thermal break strips, and it gave it a U value. So they actually tested a wall assembly to figure out how it performed. If you were to do the math on some of these systems, what you're going to find is that that equation doesn't work, because any insulation, doesn't matter what it is, that's installed in a cavity, not continuous, cannot be 100% efficient, because that framing member breaks the insulation continuity. So what does the code have to say about insulation? So we're talking specifically about metal buildings. We're looking at 2015, and for a wall assembly, we came over here, and it's telling us we need an R13 cavity and an R13 continuous. That's the prescriptive method. That's what you're supposed to do if you follow it by the rules. They gave you the option here for a U value. So if you have some other system, any other system you can think of, and it has a tested U value, you can substitute that for these assemblies. If anyone's tried to install this assembly in a metal building with 4 inches of fiberglass and a 2 to 2.5 inch piece of rigid board, all sandwiched between a horizontal girt and a metal siding, it is incredibly difficult. It is incredibly labor intensive, so most people don't use that system. They use something else that complements with the U value. Over here, we look at 2015 for roofs, and this is where we have that typical liner system. That's what we're all used to seeing. It's the white Lamtec facing, the white metal banding that gets pulled out. It gets attached to your rafters and your columns, and then that cavity insulation, the loose fill fiberglass, is stuffed in between your framing members with a second layer over top. That's our typical standard. We're going to talk about that a little bit later and some other options on how to meet that. As we look at the transition from our building codes from 2015 all the way down here to 2024, the R values are not going up significantly. Only one small change here from 18 to 21, because they increased the continuous insulation requirement by 1 R. Almost minimal, but what it did is it changed the U value by 0.02 of a percent. So you can see here, insulation values are not going up. But what the code has transitioned to is the requirements for these air barriers and these vapor barriers. I think our smoke machine shut off, but as you saw coming out of that simple 1x1 hole, those barriers are incredibly important. They can make a significant difference in that air leakage into your building. So that's where the code is going. They've realized that they've given us systems that is a whole lot of insulation. To make this work in the roof, we're typically at 12 inches of fiberglass. To make it work in the wall, we're over here at about 9 inches of fiberglass. So they've said that's about what we can physically put in with those systems. So let's go a different way. Let's require air barriers, let's require vapor barriers, and let's make the envelope tighter. So we touched on it in one of the slides earlier. In a metal building, you have 3 solutions for your envelope. All 3 solutions are acceptable, they will meet code, and you can install them. They all have different positives and negatives, which we're going to go through, but it's your fiberglass liner systems with single skin metal panel, your rigid board insulation with single skin metal panel, and your insulated metal panels. So those are your 3 paths. All 3 meet air barriers, vapor barriers, and thermal barriers. If you're not familiar with any one of them, come see Mike or I a little bit later and we can go through some of those details. But this is the leading fiberglass system. Some of you may be very aware of Thermal. You've probably installed their systems already. They have the new Max-Tite air barrier system. I say new, it's probably been around for 5 years, but not many people have used it. They developed it, they went through the R&D, and they did some really good work on their testing to make sure that it would allow fiberglass to live through that 2024 generation of the building codes. So what this system is, as we saw before, we've got the white vapor barrier underneath, we've got fiberglass in the middle, and then we've got a laminated air barrier in the assembly. Now, I talked about earlier, you need to inspect these systems if you're not going to test the building with a blower door test, because you cannot get to that green air barrier to inspect it after it's done. One of the things, if you've ever installed these systems, either with the air barrier or not, you have to be very careful. I took a razor blade and cut a 1x1 hole. Everywhere in your big buildings, somebody else is cutting a hole in it, whether it's the electrician, your mechanical contractor, your sprinkler contractor, or the guy that's installing the flange brace or hanging his basketball net. It doesn't matter what it is, somebody's gonna penetrate these barriers. So we have to understand that and work through it. Here's a better picture from an isometric of a vapor barrier, a thermal barrier, and an air barrier, and a metal siding on the outside. When we look at this from a performance standpoint, and we get done a good installation, the whole thing is taped, the whole thing is done well. Here's the flashing tapes. It's gonna perform at a value here of 0.3 CFMs per square foot. Now, if you remember from one of the other slides, our code requirements are 0.4 for a blower door test. When we change, it's gonna go to 0.35. This system will take us through 2024. It is incredibly detail-oriented. There's about 14 steps to get it done, but it will work. We can keep doing fiberglass into 2024. Our next option is rigid board. Rigid board gets us completely outside of our framing assembly. You can see down here, our framing is still exposed after the rigid board is put in. manufacturers of this rigid board, you have R-Seal, is the leading brand for metal buildings, and you have Thermax. The difference between the two, the Thermax boards have a foil-faced coating, the R-Seal boards have a Lamtech coating. R-Seal boards come custom length, anything you want for your building. The Thermax boards come in 4x8 sheets and you've got to tape them together. But they're both continuous, rigid insulation that creates a thermal barrier with a closed cell foam and the facings that give us our air and vapor barriers all in one. And then we go and put a metal siding on top of it. Doesn't matter if it's a MR24 Butler roof, doesn't matter if it's a R panel that you put screws through, it still works. It has some higher material costs up front than the fiberglass, but it has some significant savings in the number of steps you do. This system has 3 steps compared to the fiberglass system that has 14 steps. Here's a quick video of a little bit of some of the edge details. With a rigid board assembly, because it's outside of your framing, you have to use some butyl caulk, just like you would on the next slide with the insulated metal panels. You can see here, there's still a tape required where we transition from a wall to a roof, and then we can put any metal panel we want on it. This system, when done properly, we all come back to done properly, because if you have a bad installation of anything, if somebody screws your car together wrong, it's not going to work, even if it was a well-designed car. Same thing goes for buildings. When this is done well, routinely we're having projects testing at that 0.1 to 0.15 CFM. So that's about half the air leakage of the fiberglass system. So you can see that's going to take us well beyond the next generation of codes as they come down. What I didn't talk about, because we didn't touch on it, but if you go into government projects, the government requirements for the Army Corps is about half of what the regular building code is. So when the building code specifies 0.4, the Army Corps is specifying 0.2 for air leakage. That's going to blow your fiberglass out, and you're not going to be able to use those systems. But that's the Army Corps, so that's not a big volume within our industry. It's a small piece, but it is something to be aware of. Third one, insulated metal panels. If you're not familiar with an insulated metal panel, I'm certain there's a couple of the manufacturers here. You've got a metal skin on the inside, a rigid foam closed cell in the middle, and a metal skin on the outside. Insulated metal panel is a 2-step process. You put some caulk and you put the panel up, and you are done with your assembly. Now, I mentioned the rigid board was slightly more expensive than the fiberglass. The insulated metal panel is slightly more expensive than the rigid board. So we kind of have a tiered approach here. We've got our lowest upfront cost, but more labor. We've got a middle option, and then we've got the expensive option. As you can see with an insulated metal panel, as they get bigger, there's significantly more equipment needed to lift them because they're getting heavy. We now have 2 layers of metal and foam all together. Some of the challenges with insulated metal panels to be aware of, you've got obviously the upfront costs, you've got some long lead times, and they are a pain in the ass to repair if you ever damage them. Hopefully you never back your truck into it. One of the things that makes them beautiful, we have attachment clips and concealed fasteners and a tongue and groove joint that makes those air barriers and vapor barriers and thermal barriers incredibly robust. However, when you damage it, you now can't get to your fastener to take it apart. So that's a drawback to this system. If you've got long-term clients that you go back and service them year after year and they expect their buildings to stay perfect, this one's going to cost a lot of money to repair when the landscaper hits it or somebody pushes a dumpster into it. So be aware of that as a potential drawback. But they certainly do make a very clean finished product. Where this product is by far better than everything else, if you're doing a freezer building, you're at negative 30 degrees inside your space, this is the way you want to go. Just go this way. Don't try and do it with the fiberglass. Don't try and do it with a plain old rigid board and through fasteners. If it's negative 30, the insulated metal panels are made for that. That's where you want to go. So here we can see some of the installation details, the same as the rigid board, because we're outside of our framing. We're going to use some butyl sealants to tie all those pieces together to make sure we have a good transition from our wall to our roof. Inside our corners, we're going to put our fasteners in, and our IMP performance, we talked about this earlier with our air barriers. We are down here at some of the lowest values overall. IMPs are a little bit harder to install than the plain old rigid board, because when you cut them, if you screw up your cut, you now are taking a panel that may be worth $800, $1,000, $1,500 for a single panel. You're throwing it out and starting over because you just cut it wrong. Nobody really wants that. So it takes a little bit more time and effort. You definitely want to measure twice and cut once when you're dealing with insulated metal panels. It is the inside of the building, the middle of the wall, and the outside of the building all in one. But it does perform incredibly well when it's done. So here we've got a comparison of those three systems. A little bit more detail. When we talk about fiberglass, we start with our 2-inch thick fiberglass. We have fiberglass blankets as thick as 9.5 inches in the industry. You can layer multiple layers of fiberglass together, and we have systems up to R47s that are performing at an O26 for our U value, which meets all of our energy requirements from a thermal standpoint. If we come over, the same thing with our R-Seal, our rigid boards, that's coming in with some really good R values. Your polyiso foams, which you're used to, that closed cell foam that's in the middle, we're getting about R7.5 per inch. Something good to remember. Over here, with our insulated metal panels, again, we've got an R value per inch of about 7 to 8, depending on the manufacturer. One of the things I'll note that I think is really important to understand, if you didn't get the efficiency of R and U values earlier, we look here at rigid insulation, 5 inches thick, R37. It's performing at a U value of 0.27. Meets all my code requirements. Over here with fiberglass, to get that same U value, we've got an R47. So that's the difference between our cavity insulation and our continuous insulation. Step over here, I'm going to try not to walk off the back of this stage. We've got our insulated metal panels. And again, we've got these same U values. You can see we have this trend here. This is about where we're maxing out at this 0.27. That's what the code has on the top end for our northern regions. That's about what we need. There are some manufacturers that make some thicker panels specifically for the freezer industry, some of the 6, 7, 8 panels, but they're not typically used in commercial construction unless it's the freezer. We'll just skip right to the bottom of this one. We talked about this earlier. We've got cost involved. We're all in construction. We all want to make some money. We're here to find those new things. Fiberglass has been around for a long time. It's what everyone is used to. If all you care about is the lowest cost, that's where you want to go. If you're building a building that is going to cover your tractor and that's all it's going to do, that's where you want to go. Now, when you start moving up, a lot of architects are specifying IMPs. They have great performance. They look wonderful, but a lot of projects can't afford them. So there is this third option, rigid insulation with single skin metal panel, kind of blends the two ends of our spectrum. So make sure you're taking a look at that as you're working through your different systems. If your customer has this for a want and a budget that's a little bit closer to this, maybe you can talk him into that middle solution that gives them the performance for the air barriers, the vapor barriers, doesn't require all of the steps and the extra effort, but still gets closer to their budget so that you can sell them that project or move on. One of the other things that we talked about was the extra steps to install the systems. We all know that there are labor issues in the trades with people not understanding all of the details. Not as many kids are coming out of high school that want to go into the trades anymore. They all think they're going to go to college and be the boss. So there just aren't as many people that want to do those jobs. So what we're finding in the industry is we're trading lower hours for higher material costs because we can substitute that and still get the projects done with less manpower. So that's one other thing to look at. If you have a manpower issue, maybe you have to spend a little bit more money on your materials and your systems to meet the energy codes, to meet the building codes, and that's how you can get away from some of those requirements for labor that you just can't find the right qualified people. So if you've never seen one, this is the setup for a blower door test that we talked about earlier. We keep going back to this assembly and how do we test that whole building? I didn't touch too much on it, but this is a picture of it. You've got a person that's going to monitor the airflow through these fans. They're going to calculate the volume of the building, and they're going to try to suck the air out of it. Now, all of those corners, all of those little arrows that we saw in the beginning of this presentation coming into our so-called house, from our walls, from our roofs, from the ground, from all those transitions, let air into the building. So for them to hold a negative pressure, they can tell how much air is coming through these fans, and they can calculate how much air is leaking into your building. That's how you do a blower door test. So that's if we do the whole building test. If we go the other way and we want to use the verification process, we talked about how we have to have our architect, our designer of record, has to show our continuous air barriers, has to show our vapor barriers, has to provide continuity at our base, our corner, and our opening and our penetrations, and they have to provide you with the instruction on what materials to use, because air barriers can be anything. It can be as simple as plastic. It can be the Dorito bag, but all of those materials work together in concert to do the entire package the architect is specifying. Now we have manufacturers. The manufacturers are responsible to give you the actual installation details. So when we talk about Thermal as a fiberglass liner system, they're going to show you what those details are on all the corners. When you go to R-Seal for the rigid insulation or Thermax, they're going to give you those proper details on where the caulk goes and where the tape goes. When you go to the insulated metal panel manufacturer, they're providing details back to the architect. So the architect specifies the system. Our manufacturers are providing those details that they've tested for the assemblies. And now we've got installing contractors. This is where the code also adds some teeth. The code is very, very specific starting in 2021 that if you do a blower door test and it fails, the person responsible that owns it is the contractor, not the manufacturer, not the architect. The installing contractor. Slightly vague over if that's the GC or the erector, but it definitely falls in that family. And if any of you are subcontractors and you work for big general contractors, you'll know that when you sign that contract, everything's your fault. If you're the big general contractor, make sure your contract says everything's that guy's fault. And that's how the industry goes, right? So this is the teeth that the building code is adding. It is the contractor's problem if it fails. Now we look back at some of those systems and we say to ourselves, how do I fix it when it's in the middle of a wall cavity? Well, the code specifies some information on that. They give you a range. If you fail, but you only fail by a little bit, you're going to do this. If you fail by a whole lot, good luck. The last person involved in this is our approved third-party inspector or our code officials. They're the ones that are going to do the inspections throughout the process. They're the ones that are going to be there on the job site. They're the ones that are going to do this test, not your code official. Your third-party testers are doing this, and they're doing your inspections, and they're going to give those inspection reports back to our designer of record, who is then going to write you that letter at the end and put their name on it and put their seal on it and say, yep, you did it right. It's going to pass, so we can get away from this test. So this kind of shows that everybody in the system has a piece. Everybody has to do their job. So we have to talk about it in the beginning. We have to start with it from front to back. But this is the person that's going to pay the money. This is the person that has to fix it when it doesn't work. And if you're a contractor and you try and take a shortcut and you don't have an approved third party that inspects it, you are not going to get your architect to write your letter and say that you're good to go. So you're going to be stuck with this test. Now think about any of the last projects you've done and this door sitting next to him. It may not actually be your wall assembly. It may be something another contractor did if you're a sub, or it may be something as simple as the concrete wasn't flat when that base angle went down, and now I've got some air leakage through the bottom of that wall. It may be a tape joint that didn't get done at the top. The contractor is responsible to fix it. That's what the building code says. So I hope all of you can understand a little bit of that severity. If you are a contractor, this is not something that can be ignored. It's not something that can be an afterthought. It has to be something from top to bottom that's part of our building envelopes moving forward. If you have any other questions, Mike and I are both over in booth 5156. It's just that way a little bit. We can gladly give you some more information on any of the 3 systems or any of the building codes that you have questions on specifically if you've run into some issues. We'll be happy to help you. Again, we're from a company called Envos Solutions. We do consulting for building envelopes. You run into any of these projects and somebody goes, I know this is an issue, but I don't know how to deal with it. I don't know what system to use. We're here to help. We will sell you solutions too. We will educate architects. If you've got a project where you have problems because it didn't get done right, that is not my specialty. I can't really help you after the fact. However, if you ask ahead of time, that's where we're good at bringing the systems together and helping you meet your budgets and meet your deadlines and all of the other pieces that have to go into a successful project, regardless if you were the owner, the contractor, or the installer in the end. So, any questions?
Stand on the rigid boards, like on the roof when you're installing, they strong enough. Right?
So of the 2 rigid boards that are common in the market right now, the Thermax board is not tested for a walkable surface, but the R-Seal is. So you can put down the R-Seal boards on the roof and then walk on them to install your standing seam roofs on top. So it is a benefit of that one system, but that's a specific product in the industry, not rigid board in general. Made me think of something I completely forgot. You cannot go to one of the big box stores and buy green rigid insulation and put it in your building. There's a very big difference between the 2 manufacturers that I mentioned, R-Seal and Thermax, because they are fire rated as Class A materials. The green dowel boards, the things that you put in your insulation, your plain old styrofoams, they burn, they smoke, they turn to flaming jelly. They are not allowed to be exposed in a building. If you've got metal on the outside, you've got drywall on the inside, you can bury that type of foam in a cavity, but you cannot leave it exposed. There are only 2 manufacturers that have the fire rating to be left exposed. So be careful of that when you start to think about rigid board. All rigid board is not equal. Any other questions? Thank you all for your time. I see an Oktoberfest sign right there. If you've been looking for your beer that I didn't give you, there's a sign right there. Go talk to those guys. If you want some chips, Mike's got them. And thank you again for coming.